Anyway, Long Island iced tea, which is favourite drink of me and Shane again. So I'm really looking forward to tasting it. And apparently there's one for everyone in the audience in college. So anyway, we'll hand over to the lads. Hopefully they make a fantastic Long Island iced tea and we can get to sample it afterwards. So over to you, Andrew Riordan and James Coady, how to manufacture a Long Island iced tea, Copen style.
I'm James, I'm a PhD researcher with Confirm, I'm in UL. And
my name is Andrew, I'm also a PhD researcher in UL. This is Coady the Cobot, aptly named. So being postgraduate students in robotics, we have two passions. The first being robotics, obviously, and the second being sitting in a beer garden having pints, which leads us to James' point.
Yeah, so this brings us on to our topic, how to manufacture a Long Island iced tea, as we call it, Cobot style. So we first want to speak about what's the difference between an industrial robot and a cobot. So obviously you've seen these in movies, like here you have the iRobot, which seems to resemble a human, but generally in manufacturing we have something like this, a robot arm. It's basic, it's simple, but it does the job. So the difference between a cobot and a robot is that a robot in manufacturing is usually caged away. If you want to get in near the robot, it has to be shut down, but a cobot is to work with humans. So it's to take those tedious, dangerous or repetitive tasks away from humans to be able to free them up for more complex tasks. And it does this by using torque sensors. So if I'm working with the cobot arm, if it strikes off me, it picks up the force and applies brakes. It also has collision detection and pinch point avoidance. Now, the downfall of this is because it does work with humans, speed and the payload is how much it can lift, is limited. But so for certain applications, it can't be used.
My bad. The particular type of cobot, the brand we're using today, is Universal Robots. Now this one is very, very inspiredly named the UR3 because it's Universal Robots and it's a 3 kg payload. Believe it or not, they have a UR5 and a UR10, which is a 5 kg payload and a 10 kg payload. This, like most cobots, actually has 6 degrees of freedom. The first here being in the base, the second in the shoulder, we have an elbow, and wrist 3, 2 and 1. Some are sold with 7, however 6 will allow you to grab pretty much any space around the robot at any point in time. So most cobots are actually made up of 3 major units. This one is made up of 4. So we're going to separate this into the arm, control box and the pendant here behind me. So like I said, this arm has 6 degrees of freedom. As James mentioned, it has multiple torque sensors, accelerometers, pinch point detection, and you can hook up other systems like collision detection, so on and so forth. On top of that, you'll see this gripper. This is what's known as an end effector. Now this end effector is not actually manufactured by Universal Robots, but instead by a third-party company. This third-party company is called OnRobot. Now, while UR didn't have any input into making this, it was made specifically for UR, and because of that, it's very easily programmable right through the pendant. Underneath here, you'll see a big, ugly mess of wires and a big metal box. Now, the big metal box is actually quite important. That big metal box has multiple I/Os. Now, before I get into I/Os, you can see it obviously draws power to the robot, so that's the be-all and end-all of the robot. The I/Os allow communication in and out of the robot itself. So for example, if I wanted a conveyor belt to run, stop the robot to do its business, and the cobot to go again, the conveyor will go, stop, send a signal through the box, which will tell the robot to do its thing. When the robot's finished, it'll send a signal back, conveyor goes again. And when it comes to the control panel, the interface, what we have here is the pendant, which is here behind me. I know it's very simple. If you can operate Facebook or Instagram off your mobile phone, congrats. You're a robotic technician. Very, very simple to use. Now, when we start the program, we pretty much want to state to the robot, what do we want to do when it starts? So we have to set parameters. We set no action because we don't want it to wait for a signal in, a signal out, any of that. We want to press go and go. On top of that, we set a payload of 0. Now, a payload, as I mentioned it earlier, it's pretty much the weight the robot, or the mass the robot has to worry about. Because this is manufactured specifically for UR, it accounts for its own mass as soon as it's hooked up. It's got a single lead in, and that's pretty much it. So once we have it set up and we wanted to go, we got to define where we wanted to go and what we wanted to do. So we'll deal with location and movement, right? So those are called waypoints, which is just a fancy name for point A, point B, point C, point D, right? So when we want to pick a waypoint, we simply select waypoint, and when we want to set it, we go to this menu. Now, setting a waypoint is fine. That's just a space in, around the robot. what we really wanted to find is the movement. There's essentially 3 types of movement. There's move L, there's move P, and there's move J. Now move L sounds really, really simple because what it is actually a linear movement. If I define point A, point B, it'll trace a perfectly linear motion between them, according to the end effect. It sounds really efficient, but it's actually the least efficient movement for a robot, simply because everything is powered off rotary joints. So in order for it to move in a straight line, everything is working overtime. Every joint has to move. Move J is the most efficient movement. It moves from A to B according to the robot's, I suppose, smallest workload for itself. And move P is moving from point A to point B in a predefined radial motion, which is how we produce perfect semicircles, perfect circular motion. Oh, yeah, sorry. So when I'm actually teaching a robot, there are 4 separate ways. Now, on a regular robot, we have 3. We have the jog buttons here, which I can press, I can move the robot. We have on the top left, I can decide where I want the end effector to be on an XYZ coordinate, pretty simple. Or on the bottom right, I can actually tell it what rotation I want each joint to go to. But because this is a cobot, I can actually hand guide it, like this. I can teach it right from here.
Alright, so enough of the boring stuff. So, we just want to talk about the ingredients we're going to be using. So, we've vodka. Everyone knows vodka. You can drink it in a shot, a mixer. We're going to use it for Long Island tea. You've gin, which everyone knows makes you cry. We have tequila. After that, then we have white rum, which you know pirates love. Triple sec. Now, me and Andy have never drank triple sec, so we just put a question mark here. We don't have use for it besides Long Island tea. We then have syrup. There's nothing funny about syrup. And then we have cola to give it a bit of a bite. And finally, we've lemon juice. And we know when life gives you lemons, make a Long Island iced tea. So we're going to start the program there now. And it is actually doing something here. So at the moment here, you can see it moving into our home position. So for best practice, when you're doing a program, you want to have it in here so you can't hit off it or whatever. But what you can see is all these joints are linear, so it takes the loads off the bearings. So we'll start the program now. We'll let it do a few movements. We'll speak about that, and then we'll speak about a few other topics too. So it's obviously going to move in, pick up the glass, bring it over, and pour it in. Now we've actually adjusted the movements and the speed of these. As we said, slow. We didn't account for the slope, so you know. Once it's done with the pour, it's going to get rid of the glass into the recycling bin because you know recycling is important.
Climate change.
But back to what Andy spoke about, waypoints. Once it was in the home position, we didn't just do a second waypoint down to the bottle because if we did, it would just cause a crash. We put in multiple waypoints to get the most efficient method or movement to get the bottle. Also, as I was saying, the rotation speed of the actual pour, we've adjusted so we get the most efficient pour. Now, we spoke about smart manufacturing, which is very focused on flexible manufacturing, but which really, if you're in a production line, you should be able to deal with multiple products and processes, but here we had to actually systematically lay out the bottle so the robot knows it, so which is not really smart manufacturing, but you know, does the job. Yeah, so what we found interesting when we looked into Long Island tea is actually the history of it and the origin. So the actual inventor of the drink is highly disputed. So some say Ransom Bishop, who's known as Old Man Bishop, created this cocktail in the 1920s during the Prohibition era in America, which we know was the banning of alcohol, selling and consuming. And during that, obviously, gang violence and murder rates increased because now alcohol was on the black market. But as a result from Americans, they wanted to find out how they could drink the alcohol without being arrested. And as a cocktail looks like an alcohol-free drink, that was the best way to go about it.
Wine in a can.
Also, because the access to alcohol was limited, when you did get the drink, you wanted it to be as strong as possible. As we all know, cocktails are very strong. A Long Island iced tea actually has a 22% alcohol percentage. Now, the difference in this Long Island iced tea from Old Man Bishop was that he used whiskey instead of triple sec.
You saw nothing, lads. You saw nothing.
Saw nothing. Which brings me to the internet trolls who would have you believe that this was true. However, in 1972 there was a very, very serious cocktail competition on Long Island in New York. Now the catch of this competition was you had to use triple sec to enter, and it invited bar people, mixologists, whatever you want to call them, and they all had to enter. And in this competition, a man with the name Robert Budd entered. Now he decided that he was going to call it his original recipe. However, in 1960, Betty Crocker saved the day, 12 years previous, as they had published a recipe which actually featured the original recipe of the Long Island iced tea using whiskey, which proved that it was not an original
Right,
recipe.
what's he doing?
No, mid-presentation I can't.
This is when a robot doesn't listen to what we wanted to do.
This is an actual bunker. When robots disobey their creators. So,
when they love their creators.
that was going to be impressive. We get the points. Anyway, back as if none of it went wrong. Betty Crocker saved the day in 1960 as it was published that it was a repeat of the recipe that had been published 100 odd years before. So anyway, at some point we do have to get on to the boring part. My apologies, we have to talk about maths. Now I know we've statisticians in the house. We're in the same boat, nobody likes us. Right, so the maths that power robots, believe it or not, are actually very simple. They're called kinematics. And that's a fancy word for matrices. We have two types of matrices that run robots. We essentially have a rotational matrix, which defines the movement of a rotational joint, or we have a translation, which is the relationship, I suppose, between one joint and another. Now, we have two types of kinematic we run off. We can input into a kinematic engine the rotational joint we want each motor to be at, as I said previously, but that's not really worth the whole pile, because then we really have to work out forward where this is going to end up being. How 99% of cobots, robots actually work is we tell it where we want it to be here. The kinematic engine does the work backwards, and bang, you're a robotic technician. So yeah.
So, that's our presentation. We want to say thank you. Obviously, Coady did too.
We hope it wasn't too content heavy. We understand a lot of these things can be very boring, and we hope we urged on the fun.
We want to say a big thank you to the organisational team, and especially Sean, wherever he is, for making us do this, because we were reluctant at the beginning, but once we decided to do it, it was actually really fun. And I think if anybody has any interest, next year definitely participate. It's fun to take a step back from work and actually enjoy the good things of life.
Any questions? Any you have?
If any questions, then thank you.
Oh, so, are there any questions for the lads? Oh, a load of questions. My two favourite questioners.
Great.
Okay, and by the way, there's a prize for best question. They get to drink the Long Island iced tea.
We would actually, before we finish, we would actually like to invite Sean for talking us into this. Here you go, bud.
Must I? Thank you. Twisties and
Might be nice.
I'm an ex-bartender, so this is... That's lovely.
Before we go to our audience questions, I have a question for Angus. Angus, does this worry you as a
It should. I don't think so.
If you think about
It can't be the personal touch, you know. Like, likely to have these on cruise ships or something similar. It'll pick up all the drinks and make a cocktail for you, you know. But it just looks completely personal. I'd say the novelty would be once off, but no.
But you won't
want to see you pulling a pint of Guinness first before you give it a go anyway, wouldn't you?
You would actually.
That's the ultimate test. That's the ultimate test.
This little guy here, you know, he won't call you up saying he's sick, hungover, give you back talk. You know.
No labour laws on this guy.
Might someone subscribe to that? Yeah.
I think you have it convinced, lads. Right, okay, to our questions. So, man in my shirt question.
Already answered.
Already answered. Drop out.
Here's a barman. I need to test it.
Go on,
There's a bit left. All yours.
naked.
He looks like a connoisseur. Or drunk. And the man from Dunalty says.
That's actually not terrible.
That's not terrible. That's a rousing review. Okay, I think we had another question, but he's got a goujon stuck in his mouth now. Perfect timing.
Do you have places marked for the bottles?
Yeah, so as I was talking, we have them marked here in pencil, which is, you know, great, but as I was saying is that the way we've run the road program is that we have to have the bottles here. So as smart manufacturing, flexible manufacturing, that's not the way it works. If you have one production line, you should be able to take multiple products and process it. So obviously you'd have to use some like the barcode readers, RFIDs, vision systems, so then we could scatter the bottles, you could say read the barcode or whatever, figure out the orientation of it, pick it up and use it. But yes, for this program, we had to put it down and systematically place them out.
Any other questions? Question there from the person hiding behind the other person. Lads, would you park their way there?
Just a slight follow-up, like, does it come with the inbuilt, like, image recognition then, or is that something you have to...
This particular one, no. There are models out there that come with built-in image recognition systems and so on and so forth. Techman Robotics actually are a great company for that. The problem with them is that they're all designed for a very specific purpose. So, for example, barcode. How far back do I need to go? Yeah, there are robots out there. Techman is a good one, but it's very fixed. It's barcodes. It's an object that you've loaded into it and run 1,000 times. Regards actual vision systems integrated into robotics, you're pretty much looking at research. That's where there's a big hole right now, is making them flexible.
Do you think there'd be a way to hook it up to the
Well, I would hope so, because that's what my PhD is.
Okay, did I see a question there?
Just out of curiosity, do you play around with having the robot try to open the bottles? Or is that more sensitive?
Again, we'd have to put in fixtures, you know, there's only a 15-minute presentation, we don't have that much effort. But yes, I'm sure you could do it if you want.
Yeah.
Like there are videos
Need a
of...
second arm though.
Yeah, there are videos of two arms working
yeah.
together in Vegas and like so that they're actually making cocktails. Just in hotels, they're now doing it, making omelets and that. So it's very flexible in what you wanted to do. It's not just for manufacturing. You know, you could be a bartender.